In problem 2, we're asked to do something very similar to what we were asked to do in problem number 1. We have to give our answer in simplest form, having started with some rational expressions, and then we need to state the restrictions on the variables. Now, your first step is always going to be to factor. Sometimes students are like, okay, and they start multiplying the trinomial by the binomial, and it just becomes this ginormous thing. And then they're going to have to factor that at the end. And that's much harder than factoring the smaller, more recognizable pieces now. So always start by factoring. So first, we're going to factor that first trinomial. You can, of course, do this by splitting the middle term, but I hope by now you can kind of look at that and realize that it factors into x plus 2, I'm sorry, x minus 2 times x minus 1, because negative 2 times negative 1 would give us a positive 2, and negative 2 plus negative 1 gives us negative 3. The denominator is already factored. It's a linear binomial. It really can't be simplified any further. Sometimes students find it helps them if they just throw those linear binomials in parentheses. Honestly, it's not necessary, but for some reason it tends to make like factors a little bit more recognizable. And then we're multiplying by that second fraction, and we need to factor that as well. I hope you recognize x squared minus 36 as being a difference of squares. So this is x minus 6 times x plus 6. And then x squared plus 5x minus 6 should factor as x plus 6 and x minus 1. All right. Now what you need to realize is that we're going to multiply. And we know that if I have two fractions, like a over b times c over d, I always want to reduce first. Now, if I'm looking at it as a, b, c, and d, it doesn't look like any of those things reduce. So I do need to realize that essentially I'm multiplying the numerators, and that will make the new numerator, and I'm multiplying the denominators, and that will make the new denominator. But if I can reduce first, that's a better choice. So we should realize that anything in any numerator can reduce with anything in any denominator if we are doing a multiplication problem. So I can clearly see x plus 6 and x plus 6 reduce, but I should also realize that this x minus 1 over here and this x minus 1 down there can also reduce. So when we say step 2 multiply, yes, but reduce first if possible, which is what we just did. So we've reduced, now we're going to go ahead and multiply. And at this point, we do have to multiply everything out. So we're doing x minus 2 times x minus 6, which if you multiply and combine your like terms will be x squared minus 8x plus 12. And in the denominator, there's not actually anything to multiply out. We've just got an x plus 2. Now, I know that that's in simplest form because we already looked at all the factors and none of those remaining factors reduce each other. So that's the product in simplest form. Now, when I state the restrictions on the variables, I need to go back and look at what factors were ever in the denominator, because every factor that was ever in the denominator is going to create a restriction on the variable, something that can't be part of the domain. So if I just go through the list, I see x cannot equal negative 2 because that would make x plus 2 equal 0. X cannot equal negative 6 because that would make x plus 6 equal to 0. And x cannot equal 1 because that would make x minus 1 equal to 0. All right, let's look at number 3. This time we're asked for a quotient. Now we're going to start the same way. We're going to factor everything. So in my numerator, I'm factoring out a 3x, which leaves behind a 2 and a negative x. In the denominator, that's a difference of squares. It's just kind of a backwards difference of squares. You've kind of got a choice with that. If you want to, you could take that and think of it as being the opposite of x squared minus 36. So if you factor out that negative, that will flip that difference around. We've seen that happen before. That might be an easier way to picture what's going on with that difference of squares. So now it's easy to see it's the opposite of x minus 6, x plus 6. Then we're dividing. All right, we're dividing by Well, first of all, I can see that I need to take an x out of that and that'll give me x squared minus x minus 2. And then I can probably factor that into two binomials. That looks like an x minus 2 and an x plus 1. Before I keep going, a lot of these trinomials are very simple, so I'm factoring them in my head. I'm sure that many of you can do that right along with me. You can factor them in your head. If you can't do that yet with these simple trinomials, that's okay. You need to split the middle term and factor it the same way we learned back in Unit 4. I'm just not taking the time to do all of that out in these note sheets because it's a skill that you should have to be able to factor on your own. Looking at that bottom trinomial, that should factor into x minus 6 and x plus 1. All right, be careful. Do not cross anything out from one to the next at the moment. We need to remember that when we divide, if I have a over b divided by c over d, that's the same as taking a over b and multiplying it by the reciprocal d over c. Before I start reducing, I should do that flipping over. The only exception to that would be if you reduce within the same fraction. So I'm looking at that second fraction and I'm seeing an x plus 1 and an x plus 1 in the same fraction. It's okay to reduce that before you flip to save yourself some rewriting. But you can't cross anything out from the left fraction to the right fraction until it's a multiplication problem. So I'm just going to rewrite that first fraction as is. And I'm going to change this to a multiplication problem. And that's going to give me an x minus 6 on the top and an x times x minus 2 on the bottom. Okay, as soon as I do that, I notice that there's an x minus 6 on the top and an x minus 6 on the bottom. So those are factors that can reduce. And then remember this. We've got a 2 minus x and an x minus 2. Remember that 2 minus x is the same as the opposite of x minus 2. That's the idea of factoring out a negative 1, which flips that difference around that we mentioned a little bit earlier in this problem. So I can reduce these if I leave a negative 1 behind, because that allows me to flip that fraction around. All right, now I can see what's left and see any reducing. Oh, wait, I see something else. There's an x here and an x on the bottom, so those also reduce. So everything from the right-hand fraction is gone. There's actually nothing to multiply out. I have a negative 1 on the top and a negative on the bottom that'll reduce, which leaves not very much. I've got a 3 in the numerator and an x plus 6 in the denominator, and that's that product in simplest form. Now, there's a lot to pay attention to when we look at the restrictions on the variables. Any factor that was ever in the denominator can generate a restriction. So let's just work our way through. If I start by looking up here, I can't have x equal to 6 or negative 6. If I look here, x cannot be 6. Well, I already have that covered, but x also can't be a negative 1. Then I look down here, and x cannot be 0, and x cannot be positive 2. So we've got everything covered. There are a lot of restrictions on that variable.